Build Your Dreams, was originally started as a battery company in 1995. BYD stormed past Tesla to become the #1 EV manufacturer on the planet. So, is BYD having the last laugh? The CEO of one of the biggest giants in the electric vehicle industry, BYD, has just announced the launch of all-solid-state batteries. BYD launched the game changer, the BYD Blade battery. These batteries are said to be capable of charging your car in just 10 minutes. This may sound like science fiction, but it's the next big leap in EV technology. With incredible range and lightning-fast charging, BYD is rewriting the rules of what's possible for sustainable transportation. But what does this mean for the future of electric vehicles, and how will it impact drivers around the world? Why is BYD switching to all-solid-state batteries? ####, why solid-state batteries? Before we get into why BYD is making this huge switch, we need to first understand what all solid-state batteries are. Most batteries we use today, like the ones in phones, laptops, and electric cars, are lithium-ion batteries. These batteries have something called liquid electrolytes inside them. This liquid helps move energy around inside the battery. But these liquid electrolytes can be a bit dangerous. If the battery gets too hot, the liquid can catch fire or even explode. This is where all solid-state batteries are different. All solid-state batteries replace the liquid inside with a solid material. This means there is no liquid that can catch fire. The solid material does the same job of moving energy, but in a much safer way. This makes these batteries not only safer, but also better in many other ways. BYD made the decision to switch to all solid-state batteries because these batteries are safer and more efficient than traditional lithium-ion batteries. Solid-state batteries need to be manufactured in extremely controlled conditions. The actual manufacturing process is also very labor-intensive, at least for right now, especially compared to traditional lithium batteries. Traditional batteries use liquid electrolytes, which can cause problems like fires or overheating. All solid-state batteries, on the other hand, use solid electrolytes. This change makes them safer and better at storing energy. The company believes this innovation will greatly improve the performance of electric vehicles, EVs, and other devices that use batteries. ###benefits of solid-state batteries. Apart from safety, another reason BYD is making this change is that all solid-state batteries are more efficient. They can store more energy in the same amount of space compared to traditional batteries. This is called higher energy density. With higher energy density, cars can drive longer distances on a single charge. Some of these new batteries can enable cars to travel more than hundreds of miles per charge, which is a huge improvement. This is especially important for people who want to use EVs for long trips without worrying about running out of power. Charging time is another area where all solid-state batteries shine. Traditional batteries can take hours to fully charge, which is inconvenient. All solid-state batteries can charge much faster, often in about 10 minutes. This is almost as quick as filling a car with gas. Faster charging makes EVs even more practical for everyday use. It means drivers can spend less time waiting and more time driving. That's not all. Besides safety and efficiency, these batteries also open new possibilities for other devices. They can be used in drones, making them lighter and able to fly longer distances. Smartphones can benefit from longer battery life and faster charging. Xiaomi is already exploring solid-state battery technology, a whole new revolutionary battery for smartphones. Renewable energy systems can also use these batteries to store more power and distribute it when needed. This could help create a more sustainable energy future by making renewable sources like wind and solar more reliable. BYD's decision to switch to all solid-state batteries reflects its commitment to innovation and sustainability. The company sees this technology as a way to lead the EV industry and stay ahead of competitors. By improving the safety, performance, and practicality of EVs, all solid-state batteries could encourage more people to switch from gasoline-powered cars to electric ones. This change supports global efforts to reduce carbon emissions and combat climate change. ###challenges associated with all solid-state batteries. Despite the incredible benefits and features associated with these all-solid-state batteries, like other batteries in the electronics industry, they also face certain challenges that must be addressed. Keep watching to find out what these challenges are. All solid-state batteries are an exciting breakthrough in energy storage. But like any innovative technology, they come with their own set of challenges that must be addressed before they can be widely adopted. One of the biggest obstacles is cost. Producing all solid-state batteries is significantly more expensive than manufacturing standard lithium-ion batteries. The materials required, such as solid electrolytes, are costly and not as readily available. It can actually pass through from the electrolyte itself. This means much higher safety and potentially much better performance. But there are other challenges. Additionally, the processes and specialized equipment needed to produce these batteries on a large scale add to the expense. This high price makes it difficult for manufacturers to offer these batteries at competitive rates. Reducing costs is a major focus for researchers and industry experts who are exploring alternative materials and production methods. Another huge challenge is scaling up production. Currently, most all-solid-state batteries are made in research labs or small production facilities. Manufacturing a few prototypes is manageable, but producing these batteries in large quantities for global markets presents logistical and technical difficulties. Scaling up involves not only building new factories, but also refining production techniques to ensure consistent quality. Until this hurdle is overcome, the availability of these batteries will remain limited. Limited durability over time. Durability over time is another issue associated with all solid-state batteries. While all solid-state batteries are known for their high energy density, they can degrade with repeated use. Tiny cracks can form in the solid electrolyte during charge and discharge cycles, reducing the battery's performance over time. These cracks can also cause energy transfer within the battery to become less efficient. Researchers are working on creating more durable materials that can withstand repeated use without breaking down. Internal resistance is a technical problem that affects the performance of these batteries. Unlike liquid electrolytes, solid electrolytes can sometimes struggle to create a seamless connection with the other components of the battery, such as the electrodes. This can result in reduced efficiency and slower energy transfer. Scientists are experimenting with different designs and materials to improve the interface between the battery's components and reduce this resistance. Things don't end there. Temperature sensitivity is another concern. Many all-solid-state batteries perform best at higher temperatures, which is impractical for most real-world applications.